Hello and welcome to the session. In today's session, we will be discussing about a very important component of structured query language, that is data definition language. And what we will focus on today's session is we will be discussing about the data definition language with the help of an example only, and we will not discuss all the commands, but we will discuss 2 or 3 important commands which are most essential when you are trying to define a database system. So let us look into the example first and then try to define something with the help of data definition language. Well, let's look into a schema. A typical schema is being displayed, right? Of university, and we have just selected 2 tables. We are not taking too many tables because the purpose is to demonstrate the features of data definition language and especially creating a table. Okay, so we want to define these 2 tables. Okay, and how the table now, you just observe the basic facts of in this particular table. Well, if you look into the student table, the primary key happens to be student identifier, that is STID, that is the attribute, right? Then followed by student name is there, then the program code is there. So this is basically the schema of the student relation, right? And then program code and the student mobile number. And the program basically consists of the primary key of program code is program code, program table, and program name followed by the fee. These are some of the fields. Actually, the attribute naming is also based on certain convention that it basically first 4 digit of your name of the name of the schema followed by the name of the attribute. But then that depends from industry to industry. So you may the purpose is to explain this particular thing. Now, when you want to define these two, this particular schema in SQL, what you would like to know first? Well, you would like to know what are the different fields or the attributes, what are their basic constraint or what are the constraints associated with those attributes, and how we can define them. Now, if you look into a particular instance of that particular relation, okay, the 2 relation, what you can see here, that student ID, okay, look numeric, but we will not be considering this field as numeric. Why? Because the student ID, suppose it starts with the 0, then it is not going to be like there are 8 digits, what you can see in this, right? Total number of digits are 8. But suppose it starts with 0, then it is not going to be displayed at all, because numeric, basically the preceding zeros are not shown in a numeric data, right? So if it is just 1 and 2, then it will be shown as just 1 and 2, whereas we want to show it as 7 zeros followed by 1, like that. Although in this case we have shown it with the help of 1, that is 1 is starting and 1 is ending right over here. Then a student name, although we have shown very small names, but then you might have to consider the length of student name field, okay? What should be the generic length of the name of the students which you would like to show. Then comes the program code. Now program code over here you can see are just 3 characters long, but once again in different situations they may be even bigger, so you really need to create a generic length for this particular thing. And finally what you see is student mobile. In this particular instance, for all the 4 students it has been left blank, so the nulls are allowed in student mobile. That's what it means. And then we have the program relation, where program code, there are 3 program code. You can see all the 3 program code, since program code is the primary key, so all the 3 are different, and same is the case with the student ID, right? And then the program names are listed over here, and then you have the field listed as far as programs are concerned. So this happens to be an instance. So if I want to define this particular, create this particular table, so how will you create these tables using SQL, right? So that is the main objective. Well, there are three basic steps which you really need to do. Step 1, define the name and data types of each attribute. So the name we have already stated, but the data type we have given hints, but what should be the data type as per SQL? That is what we need to discuss a little bit more. Then define the constraints on these relations. So the constraint, what we could see, there was a constraint on primary key already there, right? And then there may be some constraint on the fee also, right? So we may like to define that. And then we will be using data definition language to implement the table in a typical DBMS. So these are the basic three steps which are required to be followed as far as this particular information is concerned. Well, data type and constraint on the student relation. If we look into the student relation, let's look into each attribute independently. So what you see, student ID, why we have chosen character? As we want to display all the characters which are there, all the 8 characters which is the length. So even if some preceding zeros are there, they will also be displayed. Then comes, and we are not using this student ID for computation purposes. So it is better to use character. Okay. Then come the student name. Okay. And now we have defined like 40 characters for student name. Now these are too many for certain cases. So how can we save on this particular thing? This you will come to know when we will be using the DDL, that is the data definition language. Okay, then comes the program code. Once again, it is of the type character. And we have given it a length 6, although we have used 3 codes which are of length 3 only. But in the future, we may expect that this length for certain programs may be different. Okay. Now, an interesting fact is listed over here. Now, this constraint part, right? Mobile number you can see is of 12 digits. Okay, we have used a 12-digit mobile phone, and remember we won't be using it for computation, but since they are used in digital form, so we just keep them as in the digits. Okay. Now the interesting part here is that what we have is the constraint. Well, the student ID is the primary key, right? So that is a constraint. Similarly, the case of program code happens to be a foreign key. Okay, and the name should not be null. This is another constraint. Okay, then we have foreign key. It's a very interesting constraint which references program table. So we will like to see this particular constraint a little bit later. Okay, but then we would definitely like to visit this particular constraint. The second table happens to be the program. Now over here, program code is the primary key, right? And the length of this primary key happens to be just 6 characters, same as what we have used in the student table. It's not different because the program table and the student table are related in the sense that student table program code has its reference to this particular, or has its domain that is equivalent to the program code in the program table. Well, the program name happens to be character, and we have used 30 characters for that. It should not be null. And there is an interesting thing about the constraint here, that the fee is once again a decimal number, and it should be more than 1,000 and less than 50,000. So this is another constraint which we have input in this particular situation. Now, how to define various things on these two tables? Well, for that, let us understand the command create table, right? So this is the third thing. Use the following command, create table. Okay, and the first is that we create the database. because database may consist of many tables. So first we will be using create database command. Then we will be using that particular database, and this use statement will be required if your DBMS which you are using has multiple databases. For example, if you are using MySQL, then you would be required to create the database followed by use that particular database name, right? So this is how you got to create. So in our case, the name of our database happens to be the university, right? So what we are going to do, we are going to simply write the command create database university. So it is going to create the database and then use that particular database. So this is the way we can create. We have created the database. Fine. Once we have created the database, what is the next step we would like to do? Well, once we have created the database, we've got to put certain we need to know. So create command is available to us. That is the database we have created, but we have not yet created the relation. What we know that the data types are there, right? And the second thing we want to know is how to set up the constraints. Now, what are the different kinds of constraints? So let us discuss some basic constraints which are available in DDL. Okay. So the very first constraint is not null. And you remember that this particular constraint we were using or we were stating when we were defining one relation. Okay. So this column of table cannot be left blank by data entry or modification. So this particular, whatever attribute, if we specify it to be not null, you got to put a value. Unique by primary key itself is also unique. So this value will be unique across all the values in a column. Just like what I shown you, the program code in the program table, right? They were unique. If you want to put any duplicate, it is not going to allow that. Then comes the primary key. Now primary key has both these two properties, that it is not null as well as unique. Both put together forms the primary key constraint. Then comes the check constraint. It is followed by, it is basically certain condition which is put after that. Just like when we said fee should be more than 1,000 and less than 50,000, right? So this is that constraint, and default value, if it is to be specified, we have not specified that. And the final one is references. So this is basically for specifying the referential constraint which we were referring to. Now referential constraints are going to be really useful when you want to check certain things across the table, right? So how do we now declare our table or create our tables, okay, so that we can input data into those tables? So in order to do that, you need to use create table command of SQL. So we created the database. We are now starting to use the database. Next thing is to create table within that particular database. And we need to create two databases, right? Not databases, two tables we need to create. First table is going to be student, or second table is going to be program. But what we know in addition is that there is a referential or there is a reference from student table to program. So if you are creating student table first, then the program table has not yet been created. So you cannot create that particular reference. Therefore, you are going to create the program table first. And that is what we have shown in the slide. So look into the slide. This was the detail of the program relation and how it is created. So the create table program. Okay. Now look into the program. Okay. So now what we have used, program code is of the type character 6. Okay. So this may be of 6 characters and it is a primary key. So you have put a constraint. There is no comma, nothing in between, and after the first statement there is a comma, right? So this is the syntax. So what we are saying, it is very close to English. Program code, the data type of program code is character, and it is a primary key. Okay, then comes program name, and there is a VAR as before the character. This basically is ensuring that no additional character space is wasted. So this is variable character, okay, and varchar or whatever you call it in short, but it is variable character data type, which is once again character data type, which basically accepts characters as well as numeric digits, not value, numeric digits. So varchar also accept the same. However, it saves space. Suppose your name of the program was master of computer application. Now this is just 15 characters. So the rest 10 characters, the spaces will be saved. It is not going to reserve 30 character. Whereas this character field is going to reserve all 6 characters for the program code. Okay, and once again what we stated, the constraint was it should be not null. So we have specified that. So it is how close this particular statement is in English. Then comes an interesting fact, that is phi decimal 5. So we have put phi as decimal 5, all right, and the check constraint which was there, greater than 1000 and less than 50,000 is appearing over here. All right. So this is your constraint, less than 50,000. All right. And once again, you simply put a closing parenthesis and a semicolon, which is terminator of any SQL command. So what you have created, in fact, if you execute this particular statement, then you will be able to create the program table. Next, we need to create the student table. Well, the student table creation, once again, you can look into the screen, please. Okay. The student, what you see, you directly look into the create table command. Okay. Student ID, okay, it is the primary key. Student name, once again, it is a variable character. Why? Because you see the name of the students may be very small also. Okay, like we have put Ajay as one of the names. It is just 4 characters. So remaining 36 characters, not all 36, but just one more character will be used, and remaining 35 will be saved as far as database storage is concerned. Okay. Then comes the program code. It is same. Okay. Now this is a foreign key. Okay. The program code is a foreign key, and look into how we have declared the foreign key. It is the next statement, foreign key, program code. So the program code of over here is a foreign key. It references program relation or program table which you have created on the attribute program code, and there is another statement below it, on delete restrict. Now this is something which we would like to discuss a little bit more later on, but this is how you have declared, or this is how you were able to declare all the constraints. And the referential constraint is very, very important in this particular case. And I'll explain this with the help of an example also. But first, let us look into this particular example and then go back to referential actions. So our example shows the database. Okay. So this was the database which we have already stated. Now what is the case? Program code in the student is referencing program code in the program table, right? That simply means if I have, this is MCA, okay? MCA is existing over there. MCA is existing over there. Okay, MBA, there is another MBA, MCA. Suppose instead of MCA we put MDA by chance. Then there is no MDA in this particular table, right? So referential integrity will make sure that the change, like if you want to input MDA in this particular field, it will not be accepted by the DBMS, it will be rejected by DBMS. Okay, so that is what is the referential constraint is all about. Okay, so now when you are putting in data, obviously you cannot put any other program other than these three programs in this particular program code field, because it is referencing the program code field of the program table. So that is the domain which we were referring to, and this is the concept of foreign key, right? So these program codes are checked against the program code of the referenced relation, which happens to be the program. What are the advantages of this? That when you are entering data for the student, by no means you are going to enter any incorrect program code. Why? Because it will be checked. Oh, this program code does not exist. It will give you an error immediately, right? So your data is not going to be accepted in that particular case. That is the beauty. But look into the fee. What we wanted to enter was 50,000, 60,000. Technically, both these are not going to be accepted when you want to insert the data into the system. So you got to actually change your constraint to 70,000 or 60,001, then only this particular record will be accepted. So this is another learning for you. If you have put a constraint, your data is not going to be accepted by the table by using data manipulation command if you want to insert that particular data. Right? So this is the way you are trying to handle the referential constraint. Now, what is the referential action which we were talking about? It's stated certain thing. Okay. Now, the referential action basically was over here: on, delete, restrict. And there are two basic referential actions which we want to explain to you. The referential action restrict, this is the first one, which will make sure that any deletion of record in program table will be restricted in case even one record of the student table contains that program code. Okay, this will ensure that there is no violation of referential integrity during deletion of the record from the program table. The other possible action is cascade. Okay, it will delete all the records. What does it mean? Okay, so suppose you want to delete the record DIC, Diploma in Computer Science. This is not any longer on offer. So I want to delete that record. I can do that because there is no such record in the relation which was referencing it, okay, in the student table. Okay, but if I want to delete MBA from program table, there is a student who is enrolled in MBA. All right. So this particular record will not be deleted. The data DBMS will stop. Okay. You cannot remove MBA. Okay. Why? Because the referential action was on, delete, restrict. So there is a matching record here. So it will restrict the deletion. The second referential action which we mentioned was cascade. Now, if cascade had been the action, then if I remove or delete this particular record from this program table, it will remove the related MBA records, all the students' related records from the student table. So this referential action is really very dangerous. All right. So we have two referential actions. The first referential action was restricting it. That is a good referential action because the students are there. Okay. And if this particular MBA record from the program table is removed, then how there will be violation of referential integrity constraint, which is not allowed, right? So the restriction is going to be, it will give you, DBMS will give you a message, I cannot remove this particular record because there is a referencing record in the student table. So I cannot do that. On the other hand, had your referential action being cascade, it would have removed the record of the student also along with it. that one student who was MBA student in that. Now that is a very harmful action in this particular case. But in certain cases you require that. Okay. So that is why this kind of a referential action is there. Not in our student database. Okay. But in some cases it may be required. Okay. In certain cases, if you change the code of suppose MBA to let's say MFA, something like that, Masters of Financial Accounting, then MBA to MFA, that also get reflected. So change accordingly. That kind of a referential action is also there. So you can go through different kinds of referential actions which are existing as far as database management systems are concerned. DBMS provides these particular features. So now let us try to summarize what we have discussed in today's session. We have used create database command to create a database. Then we use create table commands. We created tables using create table command. Then you should use appropriate data types and constraints when you are creating the tables. Then referential constraint must be used if it exists. Then referential action must be chosen wisely, right? What kind of referential action you want to use. And then you need to use data manipulation language commands of SQL to insert, update or find data, which we have not discussed in this particular section, but you may go through this particular command. You first need to create a database. If you do not have, or if you have not created a database, obviously you cannot insert data into that particular system. With this, we end this particular session. Thank you for being with us. Bye for now.